From the labyrinth of loops to the variable valley, we'll see the cliffs of value first. JavaScript's right up your alley. Built-ins, bluff, file spas, array, archipelago. Declarations in a desert where you'll find out how far you'll go. Learn to program, take a ride, buy a ticket, step inside. All aboard, you're at the station to increase your education. Bon voyage, a skinny dip! As long as functions you don't skip on this, the JavaScript road trip.
Hope you enjoyed all of those function expressions. Now we're going to move into a little bit more difficult territory. Every so often when we code, we want to take variables from external scopes and bind them deep within inner or more local scopes of other functions. In JavaScript, the tool that we use to do that is called the closure. Now, closures are often used in building function factories, and sometimes they can be very hard to follow or very hard to trace, even hard to spot sometimes. But after you've built a few of them, you'll see that they aren't so bad. So if you're ready to plow through the snow, head on down to the Cold Closures Cove. Hey everybody, welcome to Level 2 of JavaScript Road Trip 3, the Cold Closures Cove. Guess what? Congratulations, you've already made a basic closure. A closure is a package deal. Let's take a look at one that was in a previous example we showed in the last level. So in the build ticket function that we had in the last level, you can see in our two returned anonymous functions several variables like pass and pick and all rides that were not created within the function that's being returned. That's very important. The entire contents of any of these returned functions will still be available outside the function, outside build ticket, when they get returned. When we return a function from a function, and it is complete with variables that showed up in the external function, we have a closure. So to kind of illustrate this a little bit better, let's look at a very small example of a closure. A closure will wrap up the entire local environment, complete with all of the necessary variables that came from an external scope. Here we have a function called testClosure, and in it I've just established a variable called x and assigned the value 4 to it. And then I'll return x from this function, a very simple function. Now that x variable is only local. That means it can only be accessed inside of the testClosure function. So let's take a look at that. If we were to call testClosure, we'd get a nice return of 4 as you might expect because we returned x. But if I tried to access the x variable from outside the function, I would get an undefined. That's because x disappears just as soon as the testClosure function is wrapped up. In other words, a function's local variables are just not available once the function scope has finally closed. Now let's make it just slightly more complex. So now we'll establish that same x variable as 4, and then we'll build a new function inside of our testClosure function, and we'll call that function closeX. Now inside of there, we will return the x variable, and then inside of the testClosure function, we'll return the closeX function. Now here, the inner function will be able to access the outer function's variables. Why? Because they feel like global variables to that innermost function. So when I say return x inside of the closeX function, closeX kind of looks around in its own local environment for an x and it doesn't see one. So it looks outside there to the global scope inside of testClosure, finds that x, and assigns the 4 to the x inside of the innermost function. It's really important to note that x is not stored anywhere inside of the innermost function, not even as a parameter. So now let's check out calling our external function testClosure. And if we do that and we assign the results to a new variable, checkLocalX, we know that the entire function, closeX, the innermost function, gets returned and assigned to checkLocalX. Now let's check out what happens when we call checkLocalX. We get 4. Whoa, that is crazy. This is interesting because even though testClosure has completely finished operating, its scope is closed, we can still access the local variable that was declared in that function. Why is that? Because it has been bound as a closure inside of close X. So how can we use closures practically? Well, they're very helpful in what we call function construction zones. They make the creation of very similar functions very efficient. So let's see how this works if we were to try to make some transportation modes for the cold closures cove. Let's say that we had a submarine to get across the cove, as well as a battleship, and then a giant seagull. Not only that, it is a pirate giant seagull with blue feet. Since we have these three different modes of transportation across our cove, we can make a build cove ticket maker for our different modes of transport. Here's our function. And inside that function, we would return another function that uses a name and alerts. Here is your transportation ticket via the transport, which will get closed up from the external function. Welcome to the cold closures cove name, which will be involved on a local level as a parameter. Now, our build cove ticket maker function will make a ticket maker for every single mode of transportation. There'll be similar functions, but just slightly different. So if we wanted to make ticket makers for the submarine, the battleship, and the giant seagull, we would establish three variables called getSubmarineTicket, getBattleshipTicket, and getGiantSeagullTicket, and we would call buildCoveTicketMaker for all of those variables. So now that all of our variables have ticket makers inside them, we can call getSubmarineTicket, getBattleshipTicket, and getGiantSeagullTicket to see what's inside those variables. Well, look at there, they have exactly the same function inside each variable, but that's very deceptive because bound variables and their values will not be evident inside of a stored function. In other words, examining the function's contents will not show you a closure that has occurred. In our getSubmarineTicket variable, transport actually holds submarine. And of course in getBattleshipTicket, transport is battleship, and in getGiantSeagullTicket, transport is giant seagull. Until we've actually called any of these variables that have functions in them, the name variable that is inside those functions will stay undefined. So let's change that. Let's actually call our ticket makers. Now let's show how that works. So we'll scoot our semicolons out of the way here, and we'll pass in some names, Mario, Luigi, and Bowser, to our different ticket makers. What happens now? Well, Mario gets a ticket to the submarine, and Luigi gets a ticket to the battleship, and Bowser is forced to take the giant seagull. So now that you have a little bit of information to be dangerous, with some closures, we'll give you some challenges and see you back in the next section.